Okay, all semester long, I have not made the homework questions, like 1 through whatever, mandatory. I mean, now you have to do any, a lot of fill in the blank of vocabulary questions. Because we're really going to be working with some language components. They are going to be kind of important that you're able to decipher the language and know exactly what you're talking about. So. Just so you can see what we're dealing with. You have 1 through 8 all. Now, the 5 through 8, those are actual questions. But understand how this works. Exponential and logarithmic functions are examples of non-algebraic functions, also called as blank function. The exponential function f of x equals e to the x is called the blank function, and the base e is called the blank base. What type of transformation? You should be able to do this. What type of transformation of the graph of f of x equals 5 to the x is the graph of f of x plus 1? And the formula a equals p times e to the rt. A equals perf. Gives the balance A of an account earning what type of interest? I know that you have had to, to do vocabulary questions in any subject before. Where do you find answers to stuff like that? Where? In the textbook, and usually within the chapter. You just scan the chapter, you find those words, and there's the answer. Yeah. It's in the lecture, it's in the notes. They a lot. First of all, an exponential function. So far, the text has dealt mainly with algebraic functions. Variables, x squared, polynomials, 1 over x, rational functions, square root x, radical functions. Okay? Which include polynomial and rational functions. In this chapter, we'll study 2 types of non-algebraic functions, exponential and logarithmic. What we've done is linear functions, things like y equals 3 over 2x plus 7. Okay. Polynomial functions like f of x equals 4x to the 5th minus 3x squared plus 2x. Rational functions, f of x equals 5x plus 4 over x minus 7. Rational. We've even done radical, f of x equals square root of x plus 8. Exponential. G of x equals 2 to the x. So we've been dealing with f of x equals x to the 2nd. Over there, it's 2 to the x. So an exponential function, the variable is the power. The variable changes. Here, the base changes. 1 to the 2nd, 2 to the 2nd, 3 to the 2nd, 4 to the 2nd. Over here, it's 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd. The base is always 2, 2 to the 4. Okay. That's what makes it exponential versus just a polynomial, just a square. Different kind of outcomes, different kinds of graphs. The graph of this is called a, what do we call this? It looks like, what's the name of that shape? Starts with a P. But parabola. Shape of something like this looks like. That's exponential growth. Okay. That's the difference. These functions are examples of transcendental functions. Okay, that's our question. Exponential and logarithmic functions are examples of non-algebraic functions, also called transcendental functions. That's number one. So here's the biggest definition you're going to have to know. And it's not so much you have to know, it's about the pieces. The exponential function f, so there's the name of the function, it's just f, with base a is denoted by. So for any exponential function, it's going to look like this. F of x is equal to some base a to the x power. Now, there are some restrictions, there are some rules. The base has to be greater than 0. So that means the base cannot be negative, and it can't be one more number. Can't be 0. It's got to be a positive number. So you can't have a negative base. You can't have -2 to the x. When I say -2 to the x, you cannot have parentheses -2 to the x. You can have -2 to the x because that negative is not part of the base. Remember the whole thing about parentheses that I keep yelling about, talking about? That's not in parentheses, it's not part of the base. So I can have a negative in front of it as long as it's not a negative in the parentheses. A cannot equal 1 because that would be a really boring exponential function if it was f of x equal just 1 to the x. If a was a 1, because if it was a 1, the answer would just be 1 all the time. What's 1 to the second, 1 to the third, 1 to the fourth, 1 to the fifth, 1 to the sixth? We wouldn't get that graph over there. So there's restrictions on the definition of an exponential function. It can't be a negative number. It can't be 0 to the x because that answer would just be 0. So it has to be positive, but it better not equal to 1. Those are restrictions. And that's going to be important because we're going to go to the other side of it in just a minute. X can be anything. X can be any real number. It could be positive, it could be negative, it could be 0, it could be a fraction, it could be a decimal, it could be a rational, it could be an irrational. We can do, right here, if I said, what is g of pi? Well, that would just be 2 to the pi. Unless you plug it in and get a decimal value, and that's all you get, it's just 2 to the pi. Okay? There's no point in changing it into a decimal when we want exact values if we're going to use it. Now, if you're told to round it, that's where the calculator will come in. Other than that, it's just 2 to the pi. But we can plug in any number into the power. We just have a restriction on the base. I really recommend that you go back to your announcements or emails, or if you printed it out or you know them somewhere where it's at, the table of all your powers. And again, not knowing all of them, but knowing at least through 6 would be really helpful. Okay? Knowing powers of 10 are going to be incredibly hopeful too. Knowing at least everything on your squares. The more squares you know, the easier things are going to be for you. All the way through the 25. In addition to that, you've got to know your 10 rules of exponents. You really do. Especially 9 and 10 now. Negative exponents, definitely. We did this one at the 830 class in the co-rec. Number 7. Anything and everything to the 0 power is equal to 1. Except 0. That is going to be a Christmas present on the test, unless you don't remember it. Everything to the 1 is itself. That's another Christmas present on the test, unless you don't remember that one. Changing things from exponent to radical, radical to exponent. That's going to be important on the test. All of these rules of exponents that we've talked about since the first week. So check the announcements. They've been posted. Always look at the computer over there because I haven't zoomed in. Maybe I did zoom out on me. And then I also posted this last week. I sent out a bunch of perfect powers. Your squares, your cubes, because now you have cubes, you have the 4th powers and your 5th powers. Again, not everything, but the more of these you know, the nicer things will be. Okay. Powers of 10 are equal. Okay. There are rules of exponents right there. E. The natural base E. I learned from watching The Simpsons that E is a number, not a letter. It's a number. E is approximately 2.718281128, and it goes on forever. It's an irrational number, just like pi. It has no last digit. It doesn't repeat a pattern. The number is known as the natural base. E is the natural base. E is present in nature. The function e to the x power is called the natural exponential function. That was part of the first question. How we find these question answers? The exponential function, e to the x, is the natural exponential function. Okay, natural exponential function. And the base e is called the natural base. On the calculator, you have 2 logarithm buttons, and that's where we're headed with this, logarithms. You have LOG and you have LA. LOG, logarithm, and LN, natural logarithm. Natural logarithm. E is the natural base. So E is connected to the natural logarithm. And if you look really close at the natural logarithms button, right above this LN button is E to the X in blue. So it reminds you, hey, I'm the E button. And LOG is the common log. That's the common log button. And the common log is at base 10, because right above that common log, that LOG is 10 to the x. So the LN is a logarithm base E, base 2.71828. And the LOG, the common log, is base 10. And here's the thing, we have this. If I said 2 to the x was equal to 2, then what is x equal? 2 to what power is a 2? The first. If I said 2 to what power is an 8?
Third.
2 to the third power. Because 8 can be rewritten. 8 is 2 to the third power. So this would be x has to be 3. If I said 2 to the x, so I have 2 to the first is equal to 2, 2 to the third is equal to 8. What about 2 to what power is equal to 4?
Second.
Okay, so this would be 2 to the second. 1, 2, 3. So what about 2 to what power equals 3? I mean, 3 is in between 2 and 4, so there's got to be an answer. How do we solve this? Do I divide by 2? If I have 2 to what power equals 3, how do I undo 2 to that power? I mean, I can't divide by 2 because it's not 2 times x. You don't undo it with division. I can't take the square root of it because it's not x squared. So what undoes exponential function is logarithm. Logarithms are the inverse function for an exponential function. They are the ones that undo each other. Exponents undo logarithms, and logarithms undo exponents. That's why we have them. They work together. They go together like peas and carrots, peanut butter and jelly, Forrest and Jen. So EX and H. And then when you get to interest, if you're making money, whether you're paying money, there's complex formulas, but this right here. Interest compounded continuously is the formula A equals P times E to the RT power. This first formula is if you compound interest n times per year. So if it's compounded quarterly, n is equal to 4. It happens 4 times a year. If it's compounded daily, 365. N is 365. We plug that in. So whatever n is, we plug it in for n, we plug in t, we plug in the interest rate, plug in the principal. When it's compounded continuously, that means every second of every hour of every minute of every hour of every day, it's always being compounded. And when you let n approach infinity, you end up with e. That's where e comes from, is when you let those values of n approach infinity. So it's kind of a calculus concept. But the last question of before, A equals P times E to the RT, gives the balance of an account earning what type of interest? Compounded continuously. Number 4. But let's look at number 3, which you should know. Horizontal and vertical transformations. If you mess with X, is it going to go up and down or left and right? If I change the value of X when you're graphing, left and right, X minus H is what we would have here. So what's going to happen if I see X plus 1? It's going to go left 1 unit. because it's a built-in negative. H is a -1, so it's going to go left 1 unit. Okay, that's all they're asking you here. Now the rest of 4.1, there we go. Plug it in. Calculator, come here. Here's one. Number 6, 1.2 to the x, and we want 1/3. So number 6, f of x is 1.2 to the x. And we want f of 1/3. So that means we just want to type in 1.2 to the 1/3 power. On my calculator, parentheses is definitely, in what I have to use. Some of you have nice calculators. When you press the exponent button, it actually pops up higher and you type it in as a fraction. So all I'm going to do is type in 1.2. The exponent is this little, it's called the hat, little arrow pointing up to the, and since I need the whole thing, 1/3, parentheses, 1/3. Because if I don't put parentheses around it, it's only going to raise it to the 1 and then divide the whole thing by 3. And the directions say round to 3 decimal places. 3 decimal places. So that's here. Is it going to round up to a 3 or stay a 2? So it's going to be 1.063. Number 8. We have h of x is 8.6 to the -3x. Now we want h of -2. What you should really do is write it first. Write it out. So 8.6 to the -3 times -√2. So simplify this before you punch it up. What's a negative times a negative? So this is going to be 8.6 to the +3 times √2. I used to be able to write that. 3 √2. No parentheses. But if I write it down and then punch it up or simplify it, it works out so much nicer. So 8.6. And then the power of parentheses of 3. And then I go square root of 2. Close the square root parentheses and then close the exponent. And before you start going, oh, would it be that big? Well, 3 times square root 2 is bigger than 3. Okay, so I'm raising 8.6 to something bigger than 3. 8 to the second is 64. 64 times 3 is a lot, and it's going to be 64 times 3. Or sorry, 64 times 8. So I have another 8. So that's going to be 512. So that's 512 if it was just a 3. 3 times square root 3 is practically almost a 6. But almost a 9. 8.6 is almost 9. 3 squared 2 is almost 6. So this is almost 9 to almost 6. It's going to be a big number. So yeah, you're right there. If you have any doubts, retype it in or type it in with decimals. Just come up and ask. I don't think it should be this big. Am I doing something wrong? And I'll look and say, you put it in right. I can't tell you if you have the right answer, but if I saw something wrong, I could certainly say, you shouldn't have a negative there. Or what you typed as a negative is a minus, not the negative symbol. Whatever. Okay. And then we'll just have to do the other ones, 34, 35 on Wednesday. And then 3 times. Now you'll say, where do they? Oops, no. There you go. That would be great. Yeah.
Every time,
That's your point of list 3, if you had anything in the list. So second, you want to punch it, now you're going to do square root of it. So you can't put in the 3 until you get square root of it.